talking about proportions, and this was a proportion problem, because we were talking about what proportion or percentage of the packages get delivered on time. When we are writing our claims, null hypothesis, alternative hypothesis, the null hypothesis for proportions is always going to look like this. P equals something. So every time, if we are running through this proportions hypothesis test, your null hypothesis should say P equals blank. Okay, and we'll talk about what that number is in a second. The alternative hypothesis, we can write it in 3 different ways, because remember, this is what we suspect is happening. Well, if P doesn't equal whatever this number is, the alternative would be P is less than this number.
Greater.
We could say P is greater than this number. Yep. Or
divide.
we could just say P is not equal to this number. I'm just going to call this C, just to put something there. It's just a number, right? But it's the same number.
Oh, that is
Here,
just
here,
too
here.
easy.
So when you are writing your hypotheses,
Does it?
the null hypothesis should always be P equals something. And again, that's what like the claim is, or what we think, or what the status quo, nothing has changed, everything is as advertised. David, is your question?
Yeah, I don't think that makes any sense, but can age can equal to age A sometimes?
No.
Never.
Well, if it does, we're not, like, we would do all this stuff and we wouldn't get to anything at the end.
Okay.
Yeah. So we do want 2 different things, because what we're trying to do is figure out which of them is true. Or can we say that the alternative is true? Do we have enough evidence to say that? So and they're gonna be standing in opposition to each other. We're gonna say either P is this, or P is less than this, or P is more than this. And how you choose which of these to use depends on kind of the question setup. Just a second. These first 2 options, P less than, P greater than, we call those one-sided hypotheses, one-sided alternative hypotheses. And then this third one, the P is not equal to, we call that a 2-sided. Does that make sense why I would call those one-sided versus 2-sided?
Mm-hmm.
Because for the one-sided, I'm saying it's greater than, or I could say it's less than. For the not equal to, could be greater than or less than.
So it's
right?
both.
So one-sided versus
Yeah.
2-sided. Okay, Ava, do you have a question?
Yeah, I have a question about option 3. What's the difference between like greater or less and then not, the sign?
So when we write ours out, we're choosing one of these.
I know, like, what's the difference? Like, we already looking for like if it's greater or it's less, so.
These are gonna be a little stronger. So my conclusion might be, oh, I have evidence that the percentage of people with a passport is less than 50%. That's saying something different than I have evidence that the percentage of people with a passport is not 50%. That's the difference between those 2 statements.
So like the option 2 would be like not 50%, like.
Option
according to your
2
example?
here, this is greater than,
I know, like
less
according to your example.
not equal to.
So.
So let's look at our example. Okay. So looking at this again, the package delivery service is claiming that the percentage of packages they deliver is 90%. So my null hypothesis is going to be P equals, what's 90% of the proportion? 0.9. Okay, so for our package delivery example, our null hypothesis is P equals 0.9. When they're running through hypotheses tests, usually this is going to be like the claim that's out there by this business, right? They're saying it's 90%, so we're going to say, okay, we're going to believe you, but then we're going to see if this evidence actually like backs you up or gives me cause to disbelieve you. Now, the alternative is either going to be P is less than 0.9, P is greater than 0.9, or P is just not equal to 0.9. And how you choose the right one is you have to go back and look at like, well, what is this probably competitor or customer trying to, what do they think is happening? What are they trying to show? If we look at this, do we suspect that it's less than 90%, more than 90%, or are we just interested in not equal to 90%?
So it's less than.
Less than. So this case, we are thinking, I don't actually believe they deliver 90%, we think it's less than. So for this problem, we would set up our alternative hypothesis as P less than 0.9. If in this problem, it said, is this enough information to support the claim that the actual percentage of packages delivered on time is not equal to instead of less than, then that that would change my alternative hypothesis. If it said more than, that would change my alternative hypothesis. So how you choose how to set this guy up, you're gonna have to read through your example or your question really carefully, right? Yay, reading. Okay, so in our case, our null hypothesis in words is that, no, the company is correct, 90% of the packages are delivered on time. The alternative hypothesis in words is basically, the company is kind of lying or misrepresenting what actually happens. Whatever percentage of packages get delivered on time is less than 90%. So we're not saying it is 80%. We don't know, right? We're just saying it's something that is significantly less than 90%. So then we can kind of call it like, this statistic is not accurate with what you're doing, okay? So for every hypothesis test for a proportion, step one is going to be read through the question probably a couple times, write our null hypothesis, p equals some number, some proportion. Alternative, p less than, p greater than, or p not equal to. And if you read through the problem carefully, you should be able to figure out which one we're using here. Again, the alternative is what we're trying to show is the case, right? Someone is saying this thing is happening, but we think something else is happening. What is that thing we think might be happening we're trying to show? Okay, so that's step one. So we have our example. For step two, I should let my stragglers in. Step two we skipped over last week. Step two is where we collect the data. Now for us, we don't have to collect the data because we're not paid to get data in a statistic, right? But step two, we are going to summarize the data. Okay. Now, as with everything in statistics, for me to trust any of this, my data has to come from a representative sample. So like in the background of everything, I need to know that my sample was collected in a fair way, it's not biased, it's representative. So this is still going on in the background. But in step two, what we're going to be doing is we are going to be taking the data from the sample. Again, someone else collected it. We don't have time to go out and get some data. Someone else took this data from a sample, and we are going to try to use a formula, come up with a formula, to get this thing called a test statistic. And what a test statistic is let me write down this definition. This is going to be, it's a number, so this is a value that we calculate from the sample data. That we will use to reject, or, it's two words, not reject, the null, or we can also use it to support versus not support the alternative, right? At the end of this whole thing, we're gonna either reject the null, support the alternative, or if our evidence isn't strong enough, we're going to not reject the null, not support the alternative. And I do have that sheet I promised last week with sentence helpers that I will hand out before you leave. So this should help you write your conclusions.
I
Because I have
get
kind of
it.
some like standard ways of
I'll
formula.
be supporting everything.
Okay,
I even know what I'm talking about.
this
I
step
get it now,
two.
though.
Step two here, this is where the test for proportions and the test for means are going to be different. So today, we're going to use a slightly different formula to come up with this test statistic number. On Wednesday, when we're looking at, instead of proportions, we're looking at means, we'll have a different formula. But again, these aren't things we have to memorize. These are just things we have to know how to use and how to choose the right one. Okay. All right, what the test statistic is, the test statistic is going to help us get that p-value in step 3, but what the test statistic is it's kind of like the z-score. It is a form of the z-score. It tells me how far away my sample proportion is from whatever proportion we're testing. So what the test statistic is, and this will help you kind of understand where this comes from, the test statistic measures how far p-hat, which is, we didn't forget this all over a couple days off, sample proportion, right? How far p-hat is from, and now I'm going to use a symbol, a new symbol, p with this little o. I have this in the reading, right? This is called the null proportion, but basically, this is just whatever number we're testing in our hypothesis, okay? So this is saying, how far away is our sample proportion from the proportion we're testing. So this is that thing I wrote in step 1. P equals, in this case, our null proportion is 0.9, okay? So this is just the proportion we are testing. Okay? So let's actually go back to our example and figure out, we know the null proportion is just 0.9, right? So for our example, the null proportion, again, this is just the proportion that we used in our null hypothesis. So in our case, this is 0.9. How would I, or do we have enough information to come up with the sample proportion?
Yeah.
Yeah, how would we do that?
192 divided by 225.
Okay, yeah, because we know out of our sample of 225, 192 were delivered on time. So go ahead and use your calculator. For this hypothesis test, what is our sample proportion? So it's going to be 192 out of 225, and let's get at least 3 places. 853. And someone else, can we get a confirmation? A second? 853? We all agree on that? 853. Okay, great. Thank you. Okay, so we want to know, basically, what we're saying is this sample proportion, this is below the 0.9, right? What I want to know is that far enough below, basically, to give me evidence that, strong evidence, and evidence enough to call this packaging company for false advertising? Is this enough evidence for me to say, you do not deliver 90% of your packages on time, right? That's a lie. That's what we're trying to do. Okay, so in our example, if I just subtracted the null minus the sample or the other way around, that would tell me how far apart those two numbers are, correct? So if I did, going back to our little notes page, if I just did 0.853 minus 0.9, that's going to give me a negative number because it's below, right? Negative 0.4047, I think, right? So what I'm doing here is I'm just subtracting, and I get 0.047. It's negative because our sample is below the 0.9, right? So this just says this is 0.047. What? Why don't I 0.035? Let's check the 192 divided by 225. 0.853, okay. Sorry about that. All right, so this just means that our p hat is 0.047 below the null proportion. That's all that means. We subtract, we're finding the distance. However, yes?
Can you please repeat the last sentence? You said like other proportions that is below.
So our sample proportion is 0.047, which I got by subtracting, below this 0.9. All I did was subtract to find a distance, right? If it was positive, I would say, oh, it's above the 0.9.
So our PO is 90%?
0.9, yes. The PO is the thing we're testing against in your hypothesis, correct. Okay, now this is a distance, but I didn't take into account how big my sample size was, right? Because if I found this distance in a sample of 10 packages versus a sample of 10,000 packages, those would kind of mean different things, right? I need to somehow take the sample size into account. And so basically, in the reading, they get more into the weeds on where this all comes from. But if we take what we know about the sampling distribution for sample proportions, so this looks vaguely familiar, I know it's been a while, right? But we've seen this before. And we take the way we find a z-score, where was x minus mu over sigma. If we combine all that, and again, this isn't something we should do on our own, but I'm just telling you where this formula comes from. If we combine what we know about a z-score and the sampling distributions, we come up with the formula we can use. So this, I'm going to start, because this is what you are interested in. This is the formula we use to find this test statistic. So step 1, write the claims. Step 2, find the test statistic. So this is the formula we're going to use. We are doing p hat, sample proportion, minus p null. That's the p we're testing in our null hypothesis.
Right.
All over square root p null 1 minus p null over n. Right? So again, combining these things up here, we come up with this formula. Okay? You don't have to memorize this, but I would circle it in your notes because you're going to want to use this when you're going through the homework and when you're working on your take-home quiz. Okay. This is what we're going to do in step 2. So notice we have to know three things to use this formula. I have to know the null proportion, that's what we're testing against. I have to know the sample proportion, and I have to know the sample size. But once we know all of that, this is just going to be a very careful plugging into our calculator, correct? Okay. What this tells me, this is going to tell me the distance in standard deviations of the sample proportion to the null proportion. So we're going to get a test statistic out, and this is the same thing we were finding with those z-scores. When we got a z-score of 2.5, that meant that our number was 2.5 standard deviations above the mean. It's the same idea here. If I get a z-score, a test statistic of 2.5, that means that sample p is 2.5 standard deviations above p null. Right? It's the same idea, yes.
Okay.
So on the quiz, can I just like put it like this? When you ask for explanation, because you just said this whole thing says that it's about the distance in standard deviation.
So I don't really ask you for an explanation here. What if I did, you could say, yes, this means it's blah, blah, blah above the mean.
What kind?
Where you're going to have to explain is the end, which is a conclusion. Okay, so let's, for our example, which was, where to go? Here, we know all these things, right? Correct?
Yes.
Yeah.
We know p hat, we know p null was 0.9, and we
Yeah.
know the sample size was 225.
Yeah.
So let's go ahead and make sure we can all practice doing this on our calculators and see if we can all get the same number. So let me just write down everything we know. So we're trying to use this formula.
I can't do.
Okay, so in our case, what I need to carefully, either in one step or multiple steps, p hat is 0.853, p null is 0.9, and then all the square root is on the bottom, 0.9, 0.9, 1 minus 0.9 over, what was our sample size? 225?
Yeah.
Okay.
Yeah.
When you put this in your calculator, you need parentheses around the top. So let's take a minute and let's make sure we are all getting the same test statistic. So parentheses 0.853 minus 0.9, close my parentheses, square root. Make sure that denominator, all of that stuff is inside the square root. So again, you can do it in a couple steps if you're having a hard time doing this all in one step on your calculator. But if you put parentheses around the top, you can also do this on
I
your
got it,
calculator.
negative 2.35.
I got also negative 2.35. So if you're getting something else, check your calculator usage. But what we should get, our test statistic is negative 2.35. So for these hypothesis tests, at the end of our step 2, because we're still on step 2, we're going to come up with a number, this test statistic. Okay, now what this means in terms of our example, this means that our sample proportion from that 225 package sample is 2.35 standard deviations below the 0.9 they're advertised percentage of delivery. Yes. What this means is that our sample proportion, 0.853, is 2.35 standard deviations below, because it's negative, right? Below
The mean.
the 0.9, the null proportion.
I got lost.
The sample proportion, p hat,
Yeah.
is 2.35 standard deviations below the null proportion. That's what that number represents.
Our standard proportion is P4, right?
Sample proportion is p hat, 2.35 standard deviations below the null proportion, which is 0.9. There's my sentence. Okay. To do all of this, remember if we think back to topic 5, we still need a big enough sample for proportions, and this is good finals review, because the final's coming up. For proportions, our rules were n times p had to be at least 10, and then n times 1 minus p had to be at least 10. So I'm not going to make you do this on your quiz, but just be aware, these two things still have to be true in order to run through this whole hypothesis test. So this is kind of going on in the background. Now if we check this, n is 225, or null p is 0.9, these are both going to be way bigger than 10. So yes, our sample is big enough, this whole thing is valid. Okay, now, that's step 2. Again, This usually doesn't take so long because we don't have to like explain where the whole formula comes from.
gotta
Usually
stop.
we use our information,
You
we
gotta
use
find the
this
key.
formula, we come out with our test statistic. That is step 2. So step 1, write our 2 claims. Step 2, use the formula, find our test statistic. Now we're gonna move on to step 3. Okay, step 3, we have to find that p-value.
Ms. Anna,
Yes.
can, like, if we check that n times p is greater or equal 10 and the other one, and then it's, but in the problem, it says it's a normal shape, like,
That's for means.
oh, that's for me, okay.
Yeah. So that's for Wednesday. Yes, I understand your question. That's for means. Okay, so we're gonna move on to step 3. And I'm gonna remind you of what we talked about last Monday, 'cause it was so long ago. Step 3 is finding this thing called the p-value. And so we have to remember what the p-value is. The p-value is a probability, and what the p-value is we're saying, okay, assume the null is true. We're gonna give this package company the benefit of the doubt and assume they're not lying to us. We're gonna say, okay, I believe you. If you actually deliver 90% of your packages on time, how likely is it that I just randomly chose a sample where only 85% of them got delivered? So the p-value is, because this is important to understand because this will help you write your conclusions.
P
The
value.
probability,
Probability.
so it's a probability, so it should be between which 2 numbers? 0 and 1. If you get something other than that, something's gone wrong. It's a probability. So the p-value is the probability of observing the test statistic we just found, or something more extreme. And that more extreme thing will make sense when I show you a couple pictures. Assuming the null is true. So the whole hypothesis test, we say, the null is true, the null is true, the null is true, unless I get enough evidence to basically say no. I have evidence to reject the null, and then if we reject the null, we can support the alternative. Okay, so what the p-value is it is the probability of getting this sample data and this test statistic we just got, assuming the null is true, and
Ooh,
the thing we need to know is the smaller the p-value, the stronger our evidence is against the null.
P value against.
We got negative 2.35. Okay. So, remember in step 1, we had like 3 different options for how we could write that alternative hypothesis. So, depending on whether our alternative was greater than, less than, or not equal to, that's going to change a little bit how we have to be careful about thinking about the p-value. The p-value is a probability. If we knew that our sample was big enough, we know that this sampling distribution thing is normal, and so we can use the table, or we can use StatCrunch to save ourselves some time. And what we're looking for is, all right, if your alternative hypothesis was p less than whatever number, okay? So if your alternative hypothesis looked like this, the p-value is the probability of being to the left of this test statistic, okay? And so if I know this is normal, and I know that z equals negative 0.235, I can just look that up on the table, right? Or I can use StatCrunch, okay? So this is, if our alternative hypothesis is p less than something, we can use either StatCrunch or the table to read this p-value off. Now, if our alternative hypothesis was p greater than some number, now I'm not looking for this left-hand tail, I'm looking for this right-hand tail. And so again, we could use the table, but we have to do, remember, we have to do the 1 minus, or we can use StatCrunch, okay? I'm completely fine with using StatCrunch. If you want to practice using the table, that's great, but I would use StatCrunch to check your p-values, okay? Here's where you have to be a little careful. If our alternative hypothesis was just p not equal to, remember we called this the two-sided alternative? That's because now I need both of these areas together to get to the p-value. So I could read this area off the table and then multiply it by 2 to get to both of these. or we could get it off StatCrunch,
Okay.
this area off the table and multiply it by 2. If you draw a picture before you get your p-value and make sure you know, do I want this little left tail, do I want this little right tail, or do I need both of them? That should help you make sure you are actually getting the correct probability out of StatCrunch or out of your table. Okay, so our alternative hypothesis was p less than, right? This is what we were trying to show, right? We don't maybe believe the packing company. We think that their delivery percentage is less than 0.9. We got a test statistic. Let me actually draw this on here. Okay, so our alternative hypothesis was p less than 0.9. Our test statistic was negative 2.35, right? Is that correct? Okay, so if I draw my picture, negative 2.35 is below the mean, correct? So this is negative 2.35. I want the area to the left because it's less than. Couldn't we just look this up on our table? Okay, so you might have your table, that's okay. If we look up negative 2.35 on the table, I'm getting about 0.0094. That's my p-value. I'm also going to do this on StatCrunch because I'm assuming that we're going to mostly be doing this on StatCrunch, but just be aware you can still use the table. StatCrunch is just a little more accurate. So if we go to StatCrunch, here, how do we get to that normal thing? We can forget everything. Stat, calculators, normal. And remember here we can change everything. I wanted less than negative 2.35. And we got 0.009386. Well, we got 0.0094 from the table, right? So notice StatCrunch can confirm what we got from the table. Again, I'm kind of expecting you will mostly use StatCrunch to find your p-values. That's why we have StatCrunch, to save ourselves time. We still have the table. There will be, 1 or 2 questions on the final on the no StatCrunch part with the table, so don't completely put the table out of your minds. But on this quiz and on this homework, use StatCrunch. You paid, what, $13 for it. We gotta use it to help ourselves out. Okay, that's like multiple copies. All right, so let's write that down. So we found our p-value of 0.009386. Right? Or if we use the table, we just had 0.0094, correct? This is step 3. Step 3 should end with us getting this probability out. Sorry, that's just step 3, so step 3. Step 4, back to the hard part. Well, it's all pretty hard. Step 4 is where we have to write our conclusions, okay? And there are 2 parts to this step, and then I'll hand out the sheet to hopefully help you write your conclusions. Okay. Step 1 is we have to look at our p-value and basically decide, is that small enough, right? And this is where we compare it to that alpha. So here, we say, based on the p-value, is our evidence strong enough? Or we could also say, is our evidence significant? So here is where you decide, is that p small enough to say that, yes, these results are significant. Yes, our evidence is strong enough to do all the blah, blah, blah step 2, right? And how we decide here is we say, if the p-value is less than alpha, and either alpha is given or the standard is alpha is 0.05. If the p-value is smaller than alpha, then we would say yes. Our results are significant, our evidence is strong enough. Then we have to, this is the part I'm really going to watch out for, that you guys are going to do a great job at. We have to write out our sentence, state your results in the context of the problem. So, saying, I reject H(o) is not going to get you full points for me on the quiz and on the final. What I'm looking for, and I was thinking this morning of like a good way to explain to you what I want, pretend like you were a researcher who was working for like this company, okay? So they don't know statistics, so they're paying you to like do our analysis. If I walked up to this man who hired me and I said, okay, I did your hypothesis test, and I reject H(o) and I accept H(A), he would be like, what the heck did I pay you for? That means nothing to him, right? But if I walk up to him and I say, okay, we have enough evidence to discredit the claim arrive on time and support the claim that it's actually less than 90%, that's something he can use, right? So when I say in the context of the problem, that is what I'm looking for. Pretend you are working for someone who does not know anything about HO and HA. How would you explain what we know to them, okay? All right, let me hand this out right now. This is your help sheet for, I'll put it up here, formulating your conclusions. And so what I have here that you can use on your homework, you can use on any quiz from here on out, and I think I'll just let you keep it next to you for the final, so try not to lose it. Or if you're really good at writing conclusions, you can lose it, that's fine. But if P is less than A, here are 4 different ways to write a good conclusion sentence with just a fill in the blank with whatever your alternative is or whatever your null is. If P is greater than A, that means we don't have enough evidence. Here are 4 different ways to write that conclusion. Are there other ways? Yes, but these are the most common, like on StatCrunch, and these are going to be probably the easiest to understand when you're writing out your own conclusions. So I have this for you guys. Hand them out. And then, as I'm handing this out, think about a sentence we could write